Okay guys, quick video on general multiplication rule and tree diagrams. And a lot of this again is going to be stuff that you already know. So let's start with general multiplication rule. So the probability that events A and B both occur can be found using the general multiplication rule. Probability of A and B is going to be the probability of A times the probability of B given that A already occurred. Okay, so let's look at an example. This example is probably going to be a little bit easier because they already give you the conditional probability, but that's okay because we should already know how to do that. So the Pew Internet and American Life Project finds that the probability of finds that 93% of teenagers ages 12 to 17 use the internet. So I'm just going to write down probability of internet, 93%. Use the internet, and 55% of those online teens, so of online teens have posted a profile. So let's say profile, given that they're on the internet, is 55%. Okay. We have to find the probability that a randomly selected teen uses the internet and has posted a profile. So we're looking for internet and profile. So we're going to have to multiply the probability that they're on the internet with the probability that they have a profile given that they're on the internet. So we have 0.93 times 0.55, which is 0.5115. Okay, moving on. Tree diagram. So a tree diagram, much like a sample space, I mean, they serve the same purpose as a sample space. It's just a way to model the sequence of outcomes. They do look a little bit different. I always like to think that they're maybe a little bit more organized than a way of doing a sample space. Okay, so let's consider flipping a coin twice. Okay, let's list or let's see what the sample space would look like. So I could flip a heads or a heads, or a heads and a tails, or I could flip a tails first, then a heads, or a tails, then a tails. So the probability of getting two heads is going to happen 1 out of 4 times. Construct a tree diagram. So going to be similar. The first flip could be a heads, the second flip could be a heads, or it could be a tails. The first flip could be a tails, and the second flip could be a heads or a tails. So the probability of getting two heads, heads, heads is 1 out of 1, 2, 3, 4, just the same as the sample space showed. Now with the tree diagram, I don't have to write 0.5, 0.5. If they're equally likely to happen, then you can leave these branches blank, but that's not always the case, and this is something that where tree diagrams may be different than what you've seen before. So let's take a look at this where not everything has an equally likely chance. So tennis great Roger Federer made 63% of his first serves in the 2011 season. When Federer made his first serve, he won 78% of the points. When Federer missed his first serve and had to serve again, he's going to win only 57% of the points. Suppose we randomly choose a point on which Federer served. Let's create the tree diagram first. I set it up because I attempted this video without setting it up and it looked pretty sloppy. So let's just fill in what we need to. So the first thing is, oops, let me get my pen going. Okay. First thing is that we're talking about the first kind of choices being that he's going to make his first serve or he's going to miss his first serve. Okay. Now it was 63% of the time that he made it, okay, and 37% of the time that he did not. And so because they're not equally likely, I do need to indicate what the probability of those would be. So 63% of the time he makes it, 37% of the time he doesn't. Then we were talking about him winning the point or losing the point. Well, I guess it's tennis, right? So I don't know if he loses necessarily, but we're going to put that in our tree diagram anyway. Okay. 63% of the time he makes the shot, and then if he makes the shot, 78% of the time he would win the point. So I'd have to write 78% there, and he'd lose it 22%. That's a 0, not a 6. And he misses the point 37% of the time. If he misses the point, he would then only win 57% of the time, and he will lose 43% of the time. Okay. And then the next question is going to ask us, what is the probability that Federer makes the first serve and wins the point? So now we are looking for, let me just change colors. Okay. So we are looking for, to use our let me write it over here, our general multiplication rule. So we're looking for the probability that he will make his first serve and win the point. So I'm going to shorthand this and say makes and wins. And of course, we're talking about making first serve and winning first point. Okay, so the probability that he makes it has to be multiplied with the probability that he wins the point given that he made the first serve. Okay, so the probability that he makes the first serve was 63% of the time, and the probability that he wins the point after he served was 78% of the time, and so this is going to give us 0.4914, which is approximately 49%. Okie doke, so let's take a look at one more problem like that. Then you have your check your understanding, and then we're done. Clear that out. Okay, so video sharing sites led by YouTube are popular destinations on the internet. Let's look only at adult internet users aged 18 and over. So 27% of the adult internet users between 18 and 29 years old, 45% between 30 and 49, 28% 50 and over. The Pew Internet and American Life Project finds that 70% of the internet users aged 18 to 29 have visited a video sharing site, along with 51% of the 30 to 49 group and 26% of the 50 or older. So the first thing that we're going to do is look at the tree diagram, then we'll have to come back to the example to see what we have to do next. Okay, so the first thing that we could do is fill in our age groups here. So, oops, on the wrong thing. All right, so we had 18 to 29, 30 to 49, and 50 plus. Okay, so it was 27% of the age group was between 18 to 29, 45% in this age group, and then 28% in 50 or older. And then the second choices were that they visited the video sharing sites or they do not visit. I'm just going to write not. They visit or they do not. They visit or they do not. Okay. It's still not going to be split, so we have to write our percentages again. Let's see, what was it? It was 70% of this age group visited, so 30% do not. 51% of this age group visited, so 49 did not. And let's see, 26% visited in the 50 plus, and 74% did not. That's a 4, not a 9. Okay, So let's take a look now back at the question to see what else we have to do here. Okay, so we have to find the probability that this person has visited a video sharing site. So pretty much, guys, we're looking at everybody that has visited. So we are looking at the 70% in this age group, the 51% in this age group, and the 26% in this age group. And so let's just write this a little bit more formally. So let's say visits, a video sharing site, obviously. So we know that 70% of the 18 to 29, but from the 18 to 29 age group, there were 27% in there. So we have to do quite a bit of multiplying here. So, okay, and to that, we need to add, you know what, I'm going to switch pages because I will never fit it. Okay. This is video sharing. Okay. So we're talking about the possibility or probability rather that they will visit. Okay. So we had 27% was in 18 to 29 and 70% of them visited. Then we had 45% were in the 30 to 49 age group, 51% of them visited, and then 28% was in the 50 plus, and 26% of them visited. So we just straight multiply, then we add, and we're going to get 0.4913. Okay, let's quickly go back to the other slide here. And the last problem says, given that this person has visited a video sharing site, find the probability that he or she is aged 18 to 29. Okay, so we have a conditional to take care of here. So we are looking for, let me just get my pen back here, is the probability that they're 18 to 29 given that they do visit. Okay, well, we have that part of it done. We already just found that they visit. So we would have to do the probability that they're 18 to 29 end visits. And we're going to put that over the probability that they visit, which we found already. So, sorry, it's getting a little sloppy here. I ran out of space, but bear with me. Okay, so the probability that they're 18 to 29 and they visit was this right here. So 0.27 times 0.7. And the probability that they visit a video sharing site was 0.4913. And so this is going to be 0.1890 over 0.4913, which is approximately 38.5%. Okay, guys, so just one to try on your own. It's very, very similar to that last problem. So read it, pause it, try it, and we will check the answer in class. I don't have the answer on this PowerPoint, so read it, check it, try it. We'll go over answers in class. There's two more problems after this, so I have to flip the page. Okay, after you do the tree diagram, then answer these questions. You also have this in your reading guide. And see you in class on